Okay, so let's take a look at this next section of our study of algebra here. Okay, so before we get started, even that word alone, just as a review, okay, basically just means to solve a puzzle. Okay, and I might even substitute the word problem in there instead of puzzle. So here's how you can apply math to the real world, right? I've talked about it before. So you have to go and buy lumber for your house. Say you guys own a house in 10 years, and you have to buy lumber to build a fence. The puzzle would be, how much lumber do I buy so I don't buy too little or too much? Because if I got to go back to the lumber store, that might cost me gas. So it's important to me how much of something or how little of something I need to buy. If I'm baking a cake and I'm modifying the recipe I have because, well, this is a recipe that can make brownies, but I have to bake for, say you have children in the future, my son's hockey team, and I've got to take this recipe and increase it so that it can feed 30 hockey players instead of the 2 that's usually in my house. That's a puzzle. That's a problem. It's a problem dealing with amounts and quantities. So that's what algebra really is. It's a way to solve puzzles. But you write things in a way that is a little bit different, okay? So it uses math, absolutely, because we're dealing with numbers. And it uses the arithmetic that we learned in the first unit. So like adding, subtracting, multiplying, dividing, possibly fractions, probably decimals, possibly percentages. Yes, but it then modifies that language. Okay, so that it's a little more improved mathematically to deal with the puzzle solving. And the biggest addition to how it modifies it is to add this idea of a variable. Okay, or the thing that's unknown. Well, something being unknown is what the whole puzzle's about. That's what we're trying to solve for the missing piece there. So algebra is really that, right? It's that idea of solving for the puzzle. And in doing that, the most important thing is a couple key words that'll help you with this, including the one that we worked on a lot last week, balance. Okay? Balance is really important. What you do to one side, you have to do to the other to keep it in balance. If you keep that concept in mind, your algebra will get easier. Okay? You just kind of keep that always in mind. Don't let things get out of balance. Okay? The other one that we talked briefly about last time, and again we're going to talk about really important today, is the idea of doing the opposite. Okay? Doing the opposite will always be something you can do in math. If you can add, you can subtract. Right? If I add 4, I can subtract 4. If I can subtract 4, I can add 4 back in. That's the opposite. Okay? Opposite combined with balance is kind of how we're going to get to the whole idea of solving. Okay? We've gone over this before, but I just wanted to keep that in mind. Big picture, that's what we're talking about here. Solving problems, keeping balance, and doing the opposite. All right, so now, this is not a long presentation today, but we're going to take a look at how this applies now at the next level of solving algebra problems. Okay, so last time, and you guys worked on the worksheet for this, the method of solving was a 4-step method. Okay? Basically, do any arithmetic you can first before you get started. So this just get the arithmetic out of the way. Remember, you can't do arithmetic with a variable because you don't know what it is. Then add or subtract from both sides, that's the balance part, by doing the opposite. So if it says plus 4, you do a minus 4. If it says minus 5, you do a plus 5. When the variable's all alone, you've solved it and you're done. And then you should check it. You should go back and check to make sure you got the right answer. This relates back to part 1 of this unit where we talked about sort of 5 steps of problem solving. So here's 4 steps to solving the equations. Okay, and speaking of which, now you got to watch out because when you get into grade 9 math, your teachers are going to use fancier math terms like equation, inverse, and isolate. So inverse just means opposite. That's all it means. The inverse is the opposite. Isolate just means put it by itself. That's what isolate means. And an equation is just algebra that you write with an equal sign. So the second you use an equal sign, you're making what's called an equation. Equal means equation. All right. That was last time. So today we're going to talk about multiplication. In algebra, this is often the most confusing part for new students in studying algebra, is why is multiplication so different? Well, we already talked a little bit about this. In order to avoid confusion, because the x is now possible as a variable, and it's actually the most likely variable, we don't use the symbol like that little cross, to represent multiplication anymore. Once we get past arithmetic, we abandon that symbol. We also abandon, for the most part, the little star and the dot. They still are around a little bit, but we basically abandon those. So if I want to have 2 and multiply it by 4, what I used to use was that symbol. That's no longer allowed. Like I said, that's a banned symbol. On a computer, you might use that symbol, or on your calculator. That's a banned symbol. And some math teachers might write a dot. That's a banned symbol. What we can't do is just take the 2 and the 4 and use no symbol, because then I think it's 24. I get confused. I don't want to put a symbol in between. So what I can do, if it's 2 numbers, what's approved is I can use brackets. Brackets mean 2 times 4. Okay? Now, the same thing comes up if I have a 2, okay, and I have a variable or an unknown. Once again, I can't use the x, can't use the star, and I can't use the dot. But some math teachers still do. Some math teachers might use the star because it might get away with it. Some math teachers might use the dot because you can get away with it. But you can do this, 2x. That's allowed because you're not going to get confused. You realize this means 2 times x. Now you could still use brackets as well. You could also do that, 2 times x, or that. But basically all I'm getting at is these symbols up here are now banned in algebra, okay? Which isn't exactly true. Some math teachers might still use them. But if you just keep in mind that those are not good symbols to use, it's less confusing. Yes?
When you put 2 numbers together, does that always mean times it?
Well, it does, but you can get confused if you see that, right? Because you might think it's just 24, not 2 times 4. So the brackets help you to not be confused. But the second you have a variable, then you're not going to get confused anymore, because now it just means 2 times x. That's what it means, okay? So that's, again, I can see why that gets confusing to you, okay? So basically, in algebra, multiplication is written differently. You write it either directly beside each other, like 2x, or you use brackets, like this, 2 bracket 3, which means 2 times 3. Okay? You have to get used to that, because once you start algebra, that's the way it's going to get written. Okay? Now, when we talked about brackets back in the first unit, okay, the brackets indicate a package as well, and we'll get more into that later, but we also can use brackets to solve for things. So, for example, if I told you there's a formula 2x, and then I told you x was 5, in order to solve it, what you could do is write the original, 2x, then rewrite the original, but in this time, instead of writing x, you write the 5. But so I don't get confused and just say my answer is 25, I use the brackets to say, oh, it means 2 times 5. Okay? So that's, again, you using the way you can write it in algebra. And then I can just do the math. 2 times 5 is 10, and I'm done. Okay? But what if I didn't know what x was? What if I was given 2x equals 10? Well, right away, you guys are smart enough to figure out it's 5, because we just did that. And you may be able to use the old guess and check way, but I think as the math gets harder, we need a better method. And so what if we can just use the method we already know? And so I'm going to teach you how to do that. Okay, so 2x equals 10 basically means 2 times something is equal to 10. That's what it means. So we are still going to use our whole opposite method. Okay? So for example, when we had a question back like this one, we would do the opposite, which was what? How would I solve that? I would subtract 5 from this side, subtract 5 from this side. That's the balance part. Balance one side with the other. The 5's go away, and I'm left with x, and 20 minus 5 is 15. We subtracted 5 because subtracting is the opposite of adding. And remember, whatever we do to one side, we have to do to the other. So I did that there. Then let's try another problem. What if I see this? X minus 4 equals 9. Well, I'm going to get rid of this minus 4 by doing the opposite. I'm going to add 4. But what I do to one side, I do to the other. So I add 4 to this side, and I add 4 to this side. Keeps balance. X now equals 13. 9 plus 4 is 13. And I've solved it. Well, that's what you guys did in the last worksheet. But that was just using addition and subtraction. Now, what happens when we do the opposite with multiplication? Well, if the opposite of addition is subtraction and the opposite of subtraction is addition, what's the opposite of multiplication? I bet you one of you knows. What's the opposite of multiplication? That's right, division. Look, I made a big yellow one for you. Similarly, as we'll talk later, division is the opposite of multiplication. So we don't have to change our method. We just always remember to do the opposite. Okay, so let me show you how it's going to work now. Okay? This method is called inverse operations. Again, inverse just means opposite. Okay? You don't have to call it that. I don't care. All right. So here's our steps now. I'm going to modify the steps. 1, do our arithmetic if we can. Then do the opposite. Always do the opposite. And remember, adding and subtracting are opposites. Multiplying and dividing are opposites. Positives and negatives are opposites. Okay? What you do to one side, you must do to the other. That's the balance part. So here's the important things. Opposites, balance. Again, coming in. Finally, when the variable's all alone or isolated, we're done, and then we can check it. Okay, so let's give it a try. 3x equals 15. Okay? So we don't know what x is. It's unknown. But we have a 3 there, and we got to get rid of it. We want x all alone. So this means 3x means 3 times x. So we're going to do the opposite of multiplication times by doing division. So what we have to do is, first of all, is there any arithmetic to do? No, nothing I can do there. So I do the opposite. I divide by 3. That's the opposite of multiplication. But remember, balance. So what I do to one side, I do to the other. So I divide this side by 3. Now, we don't want to overthink this too much, but by dividing this side by 3, the 3's essentially cancel each other out, leaving me with just x. And 15 divided by 3 is 5. Okay, let me try and re-explain this a little bit more. Okay? And by the way, I checked it. 3 times 5 is 15, so 15 equals 15, it checks out. Okay? So remember, fractions and division is the same thing. We learned that back last unit. So when I write it like this, 3x over 3, I'm writing the same as 3x divided by 3. But remember, as well in algebra as we don't use the little x for multiplication, in algebra we generally don't use that symbol for division anymore. We write things in fractions to represent division. So algebra makes stuff a little bit harder and easier at the same time. We write less, but you have to understand what you're writing. Okay? So this is how we write division when you're dealing with algebra. Okay? So it's a fraction, kind of. But don't think of it like a fraction. That can get confusing. Okay? Don't overthink this. When you see this, 3x over 3, just think of it as essentially canceling the 3's out. So when you see this, just go, oh, well, that just means that 3 and that 3 cancel each other out, and I just left with x. Sometimes you can overthink this. If you think, well, what's 3x divided by 3? And you get a crazy kind of overthinking thing going on there. So don't. Just know if I divide by 3, the 3's will cancel each other out. And that's what I wanted. But then remember balance. And think whatever I do to one side, I have to do to the other. Okay? And then 15 divided by 3, well, that you can punch into a calculator. And you're going to get 15 divided by 3, and you're going to get 5. Okay? So your calculator is going to help you out with that part. All right, so let's try another one. 10x equals 15 plus 25. Okay, it's getting a little harder now. Okay? Can't really do guess and check on that one per se. You might be able to. But let's go through the steps. One, first do any arithmetic. Well, I can actually do a little arithmetic here. I can add 15 and 25 together, get 40. I can do that. So now I've got it down to this. 10x equals 40. Now I have to do my algebra. Step 2, do the opposite. So instead of 10 times x, I do divide by 10. And what I do to one side, I do to the other. So 40 divided by 10. The 10s cancel, leaving me just x. And 40 divided by 10 is? Anyone? 4. And I'm done. Okay? And if you don't know how to do this mentally, just use your calculator, 40 divided by 10. So now I've got x all by itself. It's alone, and I've solved the problem. I can check it. I can rewrite the original. 10x equals 15 plus 25. But instead of writing an x, I put brackets in the 4, because 4 is my answer. 15 plus 25 is 40, and 10 times 4 is 40. It works. It checked. Okay? So that's your process. Always do the opposite. Now, last thing today is about division. So we did multiplication. We learned a few things. Fractions and divisions, same thing. They mean the same thing. Division is the opposite of multiplication. So when we do the opposite for division, we're going to be doing multiplication. In algebra, we don't use the division symbol anymore. We use it and write it like a fraction. Don't think of it like a fraction. Just know you write it like a fraction. Okay? And this also allows us to use the exact same method for solving it. We don't have to change the method. Let me show you. Here's the algebra. X over 7 in a fraction like that really means x divided by 7 equals 3. So what we do to get x by itself is the opposite of what's happening now. So what's happening now, you should know, is division. It means x divided by 7. So the opposite of division is multiplication. Okay? So first, any arithmetic to do? No. Now I do the opposite. So I multiply this thing by 7 because that's the opposite. But what I do to one side, I have to do to the other. So I multiply this side by 7. Multiply both sides by 7. Now here again, you don't want to overthink it. What's going to happen on this side is the two 7s are going to cancel each other out and leave me with just x. On this side, 3 times 7, punch it into a calculator, is going to give you 21. Okay? So let me try and explain again some of this that's going on there. And I can check it. You know what? 21 divided by 7 does, in fact, equal 3. Okay, so let's not overthink this. Don't think about it as fractions. Don't overthink exactly what's going on. But just know that you're doing the opposite. So when I see x over 7, that's division. I do the opposite, which is multiplication. Okay, to make it go away, leaving me with just x. I want the 7 to go away. Go away, 7. So what I have to do is multiplication. I do the opposite, right? This is always how you make things go away. If it's a rainy day and you want it to go away, the sun, which is the opposite of rain, makes it go away, right? So always do the opposite. So x times 7, the 7s cancel each other out, and I'm left with just x. It's simple if you simplify the way you think about it. Okay? And on the other side, it was just straight up math. 3 times 7, which was 21. That's just pure arithmetic. Okay, let's make it harder. Here's the actual algebra now. X over 5 equals 2 bracket 15 plus 10. So we go to step 1. What arithmetic can we do here? Well, we can do a little bit. We can do, if we just think about this side, we can use bedmoss. So we'll do the brackets first. 2 times 15 is 30. Then we'll go to E, which is extra. We'll skip it. D, division. Well, there is no division on this side. M, multiplication. Well, we already did that. Addition. Oh, let's do the addition. 30 plus 10 is 40, and we're done. So we just did a little bit of bedmoss to get it to here. X over 5 equals 40. So that was just our step 1. We just did any straight up arithmetic we can. We can't do arithmetic with anything over here because there's a variable there. Can't do arithmetic with a variable. So now we're in the world of algebra. So in the world of algebra, we better do our opposite. So x over 5 means x divided by 5, so the opposite is multiplication. So I multiply by 5. And then we think about balance. What I do to one side, I better do to the other. 40 times 5 is 200. And I'm done. Okay? The variable's alone. I have an answer, and I can check it. So I can punch that into a calculator, 200 divided by 5, and I get 40, which was exactly what we got on the other side, 40, and it checks out. All right, let's wrap up today. So there's nothing really new today, but I want you to be clear that when I say inverse, it means opposite. And opposite means the opposite of positive is negative, the opposite of negative is positive. The opposite of addition is subtraction, the opposite of subtraction is addition. The opposite of multiplication is division, and the opposite of division is multiplication. That's what I'm talking about when I'm talking about opposites or inverse. Our method is the same, but I've kind of changed it around a little bit, added a few more words. So now it's moving up to a 5-step method. In the next part of this, I'm going to change this method a little bit more to make it better, to make it work better. Okay? So you're really going to only just learn one method in this unit, but I'm going to keep sort of refining it, making it better. So this is the only 5 steps you need to solve every problem on today's worksheet. All right? All right.